if you remember the transportation example, and in that specific example, we decided how much item should be sent from supplier I to the demand point J, and the demand at different points are constant. So now we want to expand that specific example and make it dynamic. When we talk about the dynamic kind of modeling, we mean that some decision variables have time index, means T. So again, we import the required packages, for example, Pyomo, NumPy, and then we need to define an abstract model. I is the set of the suppliers, J is the set of the demand, and T is the set of the time steps. And as I have already explained, the demand is a parameter which is defined over the node J. Pmin, Pmax are the set of supplier constraints that specify the minimum and maximum capacity of the suppliers, and also the cost of supplier I. And also we have added a new parameter called pattern. The pattern is going to define how demand is changing, and it does have an index T, so it is defined over the model.t. And also the distance is also the parameter which is stating the distance between the supplier I and the demand J, and it is defined over real numbers. And decision variable X, which was telling us how much item are being sent from the supplier I to the demand J, it also has a T index now. Okay, so let's continue. The variable P was telling us how much each supplier is supplying, no matter it is being sent to which demand points. The P bounds are, this is a function which we have already defined it in order to specify the bounds of my variables. Okay, so if we continue, we do need a rule C1. That rule is telling us how much it is going out of supplier I at time step T. Okay, so the summation of model.x Tij for all the J's to all the demands that I'm sending the items, and which should be equal to model.p over T and I. So as you can easily see that this specific expression is defined over T and I. That's why my function is defined over T and I. And for the same reason, when I want to define my constraint C1, I have to define it over model T, model I, and the rule is rule C1. Okay, so next constraint is telling us what? It is telling us that whatever is reached to the demand point J at time T, so the variation of the whole demand is modeled this way. So a constant number multiplied by something which is changing with time. So the summation of the model X for every I in the model I. So it means that whatever is being sent from different suppliers, that demand should be bigger than equal to the quantity of that demand at time T. And this means, and actually if you look at this constraint, it is defined over T and J. There is no I is left in this expression because we have done the summation over I. Okay, so since that expression is defined over J and T, that means that this should have T and J here, and the order of them should be exactly the same as the constraint model T and J here. Okay, and finally the objective function is somehow similar to the previous one, means that the summation of the operating cost P multiplied by the cost of the production over summation over all I and all T, plus the summation of xtij multiplied by the distance, which is also telling us how much cost is happening, and do the summation over I, J, and T. Okay, so actually when we run the objective function here, that should be very easy because the model .of, it is a variable that is telling me how much is my overall cost, and the sense of the optimization is minimized. Okay, now what we need to change compared to the let's say static kind of version of the transportation problem is to update my dat file. So the only thing that I need to change is giving and providing the Pyomo the pattern of the demand. It is assuming that it has only 6 time steps, 1 2 3 4 5 6, and the pattern of the demand is also specified here. And I change the name of the dat file and I call it here. So let me run the code. So first tab, second tab, third tab. So now the problem is solved and the objective function is found. Okay, and if I want to see the results of the objective optimization problem, you can easily see that at time t1 the values of the suppliers are specified here, 84, 84, 20, and time 2 and 3 and so on and so on. So for the time t4, when the coefficient of the pattern is 1, we should get exactly the same kind of results as we did in the static case. So I will show it to you here. So at time t1, which is the equal to demand here, the supplier 1 is 300, 620, supplier 2, and supplier 3 is 20. So let's get back to my example, 300, 620, and 20. And this objective function is the summation of the all decision variable and the cost associated with them for the whole time horizon. Okay, and there is no drawing for this specific example, but if you want, you can do it easily. Okay, that's it for this lecture.